morning, everybody. Today we're looking at factors and multiples. So first thing we're going to look at is the factors. So a number is composed of other numbers, called factors. For example, 2 times 3 equals 6. 2 and 3 are factors of 6. When a set of numbers has the same factor, it is called a common factor. The greatest common factor is the largest factor in that set that a set has in common. So basically, when I think about factors of numbers, I ask myself, what two numbers can I use to multiply together to get another number? So I ask myself, all right, what are the factors of 6? Well, what numbers multiplied together will give me the product 6? So I know 2 times 3 will give me the product 6, and that's it. Those are the only factors of 6 besides 1 and 6, because any number has factors of 1 and itself. So 1 and 6 are factors of 6, and 2 and 3 are factors of 6. So let's move on down here. It says, there are several methods to help find the greatest common factor. So it says, use a factor tree to factor 15 and 60, and then organize the factors into the Venn diagram. And I think one of the things that is going to be very helpful is this video. That's going to be able to describe this process a little bit more.
Two numbers using a Venn diagram. Let's find the GCF of 28 and 42. We have to make a factor tree for 28. We can break down 28 into its factors 14 and 2. 2 is prime, but 14 is not. So let's break down 14 into its two prime factors, 7 and 2. Now let's find the factor tree for 42. 42 can be broken down into 6 times 7. 7 is prime, but 6 is not. So we can break down 6 into its two prime factors, 3 and 2. Now let's make a Venn diagram of the prime factors. The prime factors that both numbers share belong in the center of the Venn diagram. Both numbers share 7, so 7 belongs in the shared region of the Venn diagram. Both numbers also share 2, so 2 belongs in the shared region of the Venn diagram. 28 has an extra 2, and 42 has an extra 3. To find the GCF, we have to multiply the two common factors. Those are the factors that are in the shared region of the Venn diagram. 7 times 2 is 14. So the greatest common factor of 28 and 42 is 14.
Alright, I hope that was a little bit helpful.
We can find the greatest common factor of two numbers by multiplying all of their common prime factors.
Alright, so for this example, I went ahead and factored these two numbers. And I'm going to put the primes in the circle. And prime numbers are numbers that only have factors of 1 and itself. So 3 only has factors of 1 times 3, and 5 only has factors of 1 times 5. And 2 only has factors of 1 times 2. So what she was explaining in the video is I want to fill this Venn diagram with the prime factors. And the shared region are going to be the factors that both of these have in common. So both 15 and 60 have factors in common of 3 and 5. These are prime numbers here in the middle. And the other prime numbers in our factor tree are 2 and 2. So you multiply 3 times 5, and that'll give me the greatest common factor of 15. So we have used the upside down division ladder to find the greatest common factors. I'm going to post a video on my Google Classroom on how to use this method. However, I wanted to show you another method that I think was very helpful to me in my middle school years. So what I like to do is make an organized list of the factors of both of these numbers. And the way I complete this list is from least to greatest. And I take the known factors of each number and I can plug them into the list. So 1 times 16 gives me 16, 2 times 8 gives me 16, and 4 times 4 will give me 16. And on the bottom we have 1 times 20, 2 times 10, and 4 times 5. So I can find my greatest common factor by finding the number each of these numbers share that is the largest. So when I look, I say 1 is shared, 2 is shared, 4 is shared, and those are the only numbers there that are shared. So when I go in, I like to circle the numbers so that I know which ones are shared. And then I can find out which one's the largest. So after I'm done circling my numbers, I can see that 4 is the greatest common factor between 20 and 60. All right. I didn't draw my little half circles multiplication here because there are a lot of numbers and I probably wouldn't have room on my computer on this worksheet. But I did make the list, and I can start going through and circling factors that are common between 24 and 40. So I see that we have 1 in common, we have 2 in common, we have 4 in common, and we have 8 in common. And after I'm done finding all my common numbers, I can see that 8 is the greatest number that 24 and 40 share. So my GCF, greatest common factor, is 8. On the bottom, you're going to find the greatest common factor of 24 and 6. And then for number 2, you're going to find the greatest common factor of 18, 24, and 60. And I would say that for number 2, the method I just showed you is probably the best. So make a list, circle your numbers that are in common, and identify or find the greatest number they have in common, or your greatest common factor. So that is the first side of the page on handout 1. Remember, we are looking at all of handout 1. So the next page in your packet, when you move down or turn the page, we're going to have to look at multiples. So a multiple is a number, a multiple of a number is the product of multiplying that number by another number. So the first 5 multiples of 7 are 7, 14, 21, 28, and 35. And multiples go on forever, so you can keep finding multiples of a number. And I think that the best way to find multiples of a number is to add the number to the previous number. So 7 plus 7 is 14, 14 plus 7 is 21, 21 plus 7 is 28, and 28 plus 7 is 35. The least common multiple is the smallest common multiple in a set of numbers has in common. So it says list the first 10 multiples of each number and then determine the least common multiple. So I went ahead and listed the multiples for 4 and 9. So I added 4 to the previous number in my set. So 4 plus 4 is 8, 8 plus 4 is 12, and so on. And for 9, I did the same thing. Got to start with the same number. Alrighty. So I have 9 plus 9 is 18, 18 plus 9 is 17, is 27, and 27 plus 9 is 36. So after I'm done making a list of multiples, you want to find the number they have in common that's lowest, that's the least common multiple. So I'll be looking around in each set to find the least common multiple. Alright, and I have to find numbers that these share. Well, the first number I see they share is 36. And when you find the first number they share, that's going to be the lowest number. So I know that my least common multiple is 36. So again, you just make an organized list here of multiples. Remember, multiples, you can figure out what they are by adding the previous number to the number in that set. So 4 plus 4 is 8, and so on. All right, and when I'm done making a list, I find the number they have in common that's the lowest, or the least common multiple. So for number 4, you're going to do the same thing. Create a list of multiples for 3, create a list of multiples for 7, and then find the number they have in common that's the lowest. So moving down to the bottom of the page, it says Ella and Ethan planned a barbecue for their soccer team. They purchased 60 hot dogs and 48 individual bags of chips. It says A, if each person will receive the same amount of food and there will be no leftovers, then what is the greatest number of people that they can feed? So the first thing I did here was create factors of 48 and 60, and I listed all those factors here. So I can find out that I have 12 as my greatest common factor. Now, how am I going to use that number to find out how many each person will receive? Well, if I take my greatest common factor and I divide it by the number of hot dogs there are and by the number of individual bags of chips there are, I'm going to find out how many each person will receive without having any leftovers. On the bottom, it says the Vasquez family visits their grandmother every 3 weeks and spends a day volunteering every 8 weeks. Every 16th week, the Vasquez family takes a day to go hiking. So A says, after how many weeks will the Vasquez family both visit their grandmother and volunteer? Well, they're going to volunteer 3 weeks, so I found multiples of 3, because they're going to do this continually. So I'm going to make sure that I'm thinking about that process. I'm not trying to make things even. I'm going to have things repeating. So 8 weeks, I wrote your multiples down here. So what are they asking? How many weeks will the Vasquez family both visit their grandmother and volunteer? Well, if I want to find out that number, what I want to find out is what numbers they have in common. What's the least multiples that they have in common? So in this case, when I find my multiples that they have in common the least, we have 24 and 24 here. Those are the numbers that they have in common the least. So my answer for this one will be that 12 people can be, I'm sorry, that's going to be 24 weeks. Now I'm going to do the same process down here, except I'm going to ask you to list the multiples of 16 and go through that same process of finding the number that all 3 have in common that's the lowest. So again, if you want to summarize today's lesson, I would take any information from the top about multiples or about factors. Maybe you can describe how to make a factor tree. You can describe the list I described. And for multiples, the same thing. Describe the strategy for finding multiples. You can define what a multiple is. Alright guys, that is the first day of your packet for factors and multiples. Alright, check Google Classroom for any updates about going to NRC and picking up your new packet. Remember, ask for Mr. Hart's packet. Do not accept a workbook as your packet. Alright guys, take care.